Hi friends, welcome back to my channel. We were discussing set question 2021. Last two videos we discussed up to 40th question. So in this video 41st to 57 I'm going to discuss. Actually I was planned to discuss up to 60th question, but I didn't have that much space in my phone. So let's begin. 40th question. In liquid crystal system, when the curl pitch is of the same order as the wavelength of the visible light, the liquid crystal system exhibits Bragg reflection. 41 question. An example of a one-dimensional defect in a crystal is option D, dislocations. 42. A liquid which can flow without loss of kinetic energy is exhibiting superfluidity. 43. In precision metrology, the Josephson effect provides an exactly reproducible conversion between option A, frequency and voltage. 44. BCS theory can explain superconductivity exhibited by option A, type 1 superconductors. 45. Divergent susceptibility is a characteristic of dash phase transitions. Option A, second order. Bessel's function of the first kind x jn-1x plus x jn plus 1x is equal to 2n jnx. 47. In the Kronig-Penney model, there are certain values of energy for which there are no eigenfunctions of the Schrodinger equation. These values constitute the band gap, that is option B. Next question. 48. The fraction of electrons that contribute to specific heat flow, that is Fermi-Dirac statistics. 49. The directions in which scattering from a crystal can have non-zero intensity is given by, that is the Miller indices. The answer is C. 50. The basis vectors of a real BCC lattice and the reciprocal lattice of an FCC resemble each other. Option C, in direction but not in magnitude. Option C. 51. The Bravais lattice of dash system have A is equal to B not equal to C and alpha is equal to beta is equal to gamma is equal to 90 degree. That is option B, tetragonal. Next, 52. Time dependent perturbation theory explains the effect of option A time dependent perturbation applied to a time independent Hamiltonian. A time dependent perturbation applied to a time independent Hamiltonian. Next question is 53. The theory that fails to explain collective phenomena like solitons and Cooper pairs are option C, perturbation. Next question 54. Experiment demonstrating the observation of a single eigenvalue of an initially unknown physical property is Stern-Gerlach experiment. Question number 55. An atom in an excited state temporarily stores energy if the lifetime of this excited state is measured to be 1 × 10 raised to minus 10 seconds. What is the minimum uncertainty in the energy of the state in electron volt? Use H is equal to, that is Planck's constant, 6.63 × 10 raised to minus 34 joule second and pi is equal to 3.14. Okay, so they asked to find the minimum uncertainty in the energy and it should be in electron volt. Okay, they given 6.63, that is Planck's constant they given, the value of pi they given 3.14, and what else they given, that is delta T 1 × 10 raised to minus 10 given. They given that delta T is equal to 1 × 10 raised to minus 10, and we have to find out delta I. Delta is equal to h by 4 pi into delta T. Okay, h they given 6.6 × 10 raised to minus 34 divided by 4 into 3.14 into 10 raised to minus 34. No, into 10 raised to minus 10. That is the value of delta T, 1 × 10 raised to minus 10. So this minus 10 goes to the numerator and the minus 34 and minus 10 it become 10 raised to minus 24. Okay, and here 3.14 and here 6.6. Oh, we only consider 3.1. How many 3.1s are there in 6.6? 6.6. So 3.1 into 2. 3.1 into 2 is equal to 6.2. But we already have 6.6 here. So if we cut 6.6 by 3.1, it should be 2 point something. Okay, so it should be 2 point something. Okay, 2.1 by 4. So if 20 by 4, it should be 5. Okay, here but 21 by 40 we can write like that. So it should be 5 point something. 5 into 10 raised to here minus 24 is there, minus 24. Okay, so next 5 point something, 5.1 something will be get. Okay, then next is we have to convert this one into electron volt. So we have to divide this one by 1.6 into 10 raised to minus 19. So I will erase this first. Okay, so 5.1 into 10 raised to minus 24 divided by 1.6 into 10 raised to minus 19. Okay, here 1. here we have 5.1 by 1.6. So 5.1 and 0.6. So we can write 51 by 16 into 10 raised to minus 24. Minus 24 is there and minus 19. Then it becomes 19 and 5. 5 minus 5. Okay. Minus 5. 51 by 16. 16 into 3 is equal to 48, but here 51. So if we cut 51 by 16, it should be 3 point something. Okay, so we can write it as 3 point something into 10 raised to minus 5. Okay, let's check. Oh, sorry, let's check. Okay, here they give one, we get 3 point something into 10 raised to minus 5, but our answer here is 3.3. 3.3 into 10 raised to minus 8 and 3.3 into 10 raised to minus 6. It should be 3.3 into 10 raised to minus 6. Okay, you can calculate little more accurately, then you get the exact correct answer. I am doing it this way because in exams, accurate measurement is not possible every time. If it's possible, you can do like that. Okay, next the 56th question. The moment of inertia of a circular wire of mass m and radius r about its diameter. 55. It is not 56th question. This is 1/4 m r square.